In this video, we want to use a trig substitution to evaluate this integral here. Now, obviously here it's telling you what method will apply. Some problems won't let you know, or instructions won't let you know. Now if I had an x here in the numerator, constant doesn't really matter, it's still going to work. 2x, 3x, because I know the derivative of this expression here, the radicand, is a factor of x, so that a regular u substitution will work. I don't have that. So as you go through the process again, assuming they didn't give you the method to use, you have to go through and, okay, can I use a u substitution, a trig substitution, will partial fractions work, and so forth. And you pick the one that's more obvious. Now for this one here, we already know we're going to use a u substitution, but if you figure this out on your own, here are some of the options you have for integrals involving this expression. Now you could have a radical and maybe not, or you could have this expression to the 3/2 power, not just a square root. So keep that in mind. But if it's in this form here, the square root of a squared minus u squared, then it tells you let u. Now this u here could be in the form of 2x quantity squared, but this is say u here. You let u equal to a sine of theta, and if you plug it into this expression here on the right, using the appropriate identity below here, we know that cosine squared of an angle plus sine squared of an angle is equal to 1. The second form, we know that 1 plus tangent squared of an angle is always equal to secant squared of the same angle, and so on. So the first one would be used for form number 1, square root of a squared minus u squared. The next one will be for the square root of a squared plus u squared, and there's the substitution. And then you have the third form here, and the identity, trig identity used is 1 plus cotangent squared theta equals cosecant squared theta, and that's your setup here. Now in our case, we have this form. The 16, that would be the form a squared. In this case, the x and the u would be the same. X squared instead of u squared. So we're set there. So then I would have an x. Look at the form again. It's this substitution here. U equal to a sine theta. So we come over here then, and it's u. In my case, it's going to be an x instead of a u. Is equal to 4. The 16 represents the a squared, so that means a would be 4. So this would be a 4 here. X equal to 4 sine theta. So we're converting this to an integral involving the variable theta. So then dx, that's the derivative. Derivative of sine theta is cosine. So this would be 4. It's a constant there, cosine theta and d theta. So instead of a u substitution, we're using a trig substitution, but the procedure is still the same. We want to transform the integral so that we don't have the variable x, we have the variable theta. So notice dx right here, that's going to be represented by cosine, 4 cosine theta d theta. And then we need a representation for this expression here. So let's just write it out. It's 16. Again, a is 4. 4 squared is 16. And then this is minus. And then it's x squared. And the x is 4 cosine theta. And then this is squared. So then this is going to equal to the square root of 16 minus, and then square the 4 sine theta gives me a 16 sine squared theta. And then I factor out the 16, so that would give me then the square root of 16, sit under the radical here, and this will be 1 minus sine squared theta. And then here, and we take the square root of this product here, so the square root of 16 is 4, so that comes outside the radical. We're dealing with positive values here. And in the 1 minus sine squared theta, I know that that's the same thing as cosine squared theta from that identity I just went over. Cosine squared of an angle plus sine squared of an angle equals to 1. So if I solve it for cosine squared, I get this. So square root of cosine squared of theta, that's just cosine. So that simplifies to that. Now sometimes you'll use a triangle here, right triangle. You pick your angle theta here, and the x will be here, the 4 would be here, because notice from this statement right here, divide by 4, I get sine of theta is equal to x over 4. Yeah, x over 4, so you get this. So this side then would have to be the square root of 16 minus x squared. And you would use this to simplify your final answer. In other words, convert from the theta back to the variable x. Might not need every single piece of information from that triangle in this particular problem, because it simplifies nicely here. So let's just do this then. Dx is right here. That's 4 cosine theta. D theta. That's from this step right here. So now we replace the dx, so we've got everything here in the numerator in terms of theta. And the denominator now, we can't have an x here, so we have to simplify this. Well, we did it over here. This simplified here. The square root of 16 minus x squared from right here simplifies to 4 cosine theta. So this one's going to work out nicely here. The cosine theta and the cosine theta cancel out. The 4 divide out. That simplifies to the integral of d theta, or we can say 1 d theta. And now we just integrate this with respect to theta. So the antiderivative, or the integral of 1 with respect to theta, it's like if this were an x here, this would be x. In this case it's theta, so this is theta. So the answer in terms of theta is theta plus c, constant of integration. But the original integral, it was involving the variable x. So all we have to do here is convert back to the variable x. So from this statement right here, we can say that the sine of theta is equal to x over 4. And of course we also know that from the triangle. Sine of theta is opposite over the hypotenuse. And now we want to solve for this for theta. So we take sine inverse on both sides. Well, if I take sine inverse of sine of theta, this just gives me theta on the left side. And on the right side, I'll get sine inverse, or you can say arc sine. So sine inverse sine theta gives me theta, and then there's sine inverse of, on the right side, x over 4. So come back to this statement here and replace the theta by sine inverse of x over 4 plus the constant of integration. And this is your final answer. Thanks for watching. We'll see you next time.